I built a mixture of expert mouse brain that has two separate networks, one to actually find cheese and one to stay away from predator. And the mixture of experts part of it comes in this layer where we can actually weigh the connection strengths of each network to produce the final output. Each network actually connects the three motor neurons separately, and each network learns separately. And currently, the network weight for each is actually 50%. Let's actually speed this up a little bit, give it some more chance to learn. The thing is that this actually learns pretty quickly. We have a ring attractor network for both, one of them which points the direction of the cheese, the other one the direction of the predator. All of those neurons in the ring networks connect to three motor neurons. Let's slow it down. And then the outputs, more whatever, and the weights of the connections are updated with Hebbian reward modulated Hebbian learning, meaning whichever connection produces the most reward gets boosted. In this case, getting close, reducing the distance to cheese actually gets a reward at each time step, and being away from the predator for the second network actually gets a reward for every time step. Let's actually move this to cheese focus. As you can see, I moved the slider all the way to the left. So now our little mouse should go towards the cheese without any regard to the predator. By the way, the code files for this is available at my Patreon. If you decide to become a paying member, you will have access to the source code for this, plus 500 other project files that I built over the months and years, and exclusive videos and weekly meetings. Thank you for your support if you do consider it. So let's accelerate this and turn this to predator focus. So now it actually learns to stay away from predator a little bit slower. But as you can see now, it is trying to stay away from predator, except when it's heading towards the predator, it has difficulty, I think, if they're exactly in the head-on collision type of situation. The tractor network maybe doesn't provide enough differentiation because it is lighting up as a population code. Many neurons light up in that direction. So that can be fixed by adjusting the attractor network. Let's speed this up to give it more chance to learn because it could eventually actually learn that possibly. And there are some graphs here just for fun, also to display the cheese, the distance to cheese and distance to predator. When you first initialize it, this graph runs pretty fast, but you can see the reward for cheese immediately starting to go. It learns pretty quickly how to get to the cheese. Let's slow this down to see if its behavior has changed, especially during head-on collision type of stuff. But yeah, it for the most part is learned to avoid the predator. So when we equal the focus, now it should both try to chase cheese and also try to stay away from predator. Sometimes you get really interesting behaviors, such as this circular behavior, especially when it wants to get to the cheese, if the trajectories are just right. Anyway, overall, this is an interesting project I wanted to share with you all. I like to explore this mixture of experts kind of stuff even more in detail with other projects because currently we are deciding the strength and by the strength of each network on the final outcome. However, and by default, it's each network contributes 50% to the final decision. However, I mean, you can imagine there could be more than just two networks, and there could be an overarching network that actually gates the situation more intelligently. So I will be exploring these in future projects. Thank you for watching this. And again, the source code for this will be available for paying patrons at my Patreon. Link will be below in the description and in the comment. But if you do, you can also become a free member, and I have quite a lot of open source projects that you can download there as well. Thank you for watching. See you in the next video.